Hello, welcome to Science Chomp. Today we're going to be looking at the differences between ionic compounds and molecular compounds. Molecular compounds are also known as covalent compounds, so this is just something that you need to bear in mind. So let's begin. On this side I've got all the details that you need to know for ionic compounds, and over here molecular compounds, or molecules as we call them. Okay, so ionic, examples of ionic are things like sodium chloride and magnesium oxide. And take note, you've got a metal connected to a non-metal. Metal connected to a non-metal. And that's what I've got written here. Okay. The way they combine together is that they form ions. So the sodium atom would form a sodium ion, and the leftover electron would jump ship to the chlorine. So you have a very strong bond because this one becomes positive and this is negative. So whenever you've got positive and negative charges coming together, that forms a really, really strong bond. As a result, when you've got a strong bond, the compound tends to have a very high melting point and a very high boiling point. Okay, I've written melting point here, high melting point. Also, it's true for the boiling point as well. Okay, they usually are in the form of solid crystals as well. So if you pour out salt onto your hand and you examine it with a magnifying glass, you'll see that each grain is very crystalline in structure. So that's what ionic compounds look like. Okay, and finally I've written down here electrical conductivity. Now this is true when you dissolve them, but as they are just in their solid state, they won't conduct electricity. So if you dissolve it in water, what it does is it mobilizes the ions. So you have all these charged particles floating around in the water, and electricity is basically the flow of charged particles. So when you dissolve it in water, the charged particles can flow from one electrode to another, which means it conducts electricity when it's dissolved. Also when you melt them as well, this would be the case. Okay, now over to the covalent side, and we've got carbon dioxide, we've got water, we've got this thing, C6H12O6, which happens to be sugar or glucose. Now all of these, the carbon, the oxygen, the hydrogen, these are all non-metals. So when you have a non-metal connected to a non-metal, that would be a molecule or a covalent compound. Okay? The way they bind together, they join together by sharing electrons. So none of these have a full shell of electrons, but they share electrons between themselves, so they can basically share the benefits of the full shell having that stability. They usually have low melting points. You can melt sugar much more easily than you can melt salt. Okay, you can try it if you want at home. Salt, you're not going to melt it. This thing is quite easy to melt. Okay, so low melting point. But as you can see, this one's a solid. You know, sugar is a solid. This one's a liquid. This one's a gas. So covalent compounds can exist as solids, liquids, and gases at room temperature. So that's around 20 to 25 degrees centigrade. Okay? And finally, it doesn't matter if you dissolve them or not, they are poor conductors of electricity. And that's basically it for the differences between ionic and covalent compounds. Hope that made a lot of sense, and I'll see you in the next video. Goodbye.